Let us start. We have started the discussion on the cooling load estimation. Now, first of all, we have discussed in this chapter now we have talked that what is the total heat removed, which you are supposed to remove from the space, maybe inside a room or inside the space of a refrigerator. What is the heat required to be removed is defined as the cooling load. What is the heat? The total heat required to be removed is defined as the cooling load. Now, the purpose of the cooling load estimation is the purpose of the estimation is to calculate the size of the air conditioning system, size and the air conditioning and refrigeration system that is required to maintain the inside design condition during the period of maximum outside temperature. The design load is based on the inside temperature the design load is generally based on the inside and outside design conditions, and it is the air conditioning refrigerating equipment capacity to produce the maintenance satisfactory inside condition. So what we are supposed to do, we have to know the amount of heat we are supposed to remove in order to know the calculate. That is known as the cooling load. It is the requirement for this, to know this cooling load is to know the size of the refrigeration system to maintain inside design condition. The design load is based on inside and outside design condition, and it is the air conditioning and refrigerating equipment capacity to produce and maintenance a satisfactory interior condition. Actually, the design load, it depends on the outside design condition and inside design, both of them, and it is the capacity to produce a necessary inside condition. Outside condition, you don't have anything to say. Now, there are two components we have discussed that as cooling load. We have two components of the cooling load. One is the sensible heat gain. The heat is the direct addition of heat to the enclosed space. Maybe a gain in the sensible heat said to occur. The sensible heat is to be removed during the process of summer air conditioning. This again may occur due to any of the reason. So some of the heat will come inside a enclosed room. So in terms of a sensible heat, not in terms of a latent heat, first, next in terms of a sensible heat means outside condition somewhere is hitting the inside condition of the room. So you have to know in full details in order to make the room cool. How it is like this, how the heat is coming inside a room from the outside condition. Heat is always flow through the building by the construction, building side, floors, ceiling, everything. It is hitting the inside of the room, and especially due to the temperature loads on these two sides. Maybe from the temperature difference between the inside and the outside, the heat is flowing coming from the outside through the door, through the walls, through the windows like this, and it is received from solar radiation due to the extreme high temperature of heat, surrounding heat. It consists of the heat transmitted directly through the glass of windows It is transmitted directly through the glass of the windows, the ventilators or doors, and the heat absorbed by walls and roofs. Heat transmitted directly through the glass of windows, the ventilators, mm, through the glass of windows, ventilators, and ventilators directly through the glass of windows, ventilators, and the heat conducted through interior parts. Next comes, first of all, uh, directly through the glass of windows, mainly ventilators, sometimes some ventilators, sometimes also from the door itself. The door, this solar radiation of heat is absorbed by the walls of the building. Walls of the building, sometimes it will transfer to the room. Next condition is through the interior partitions. The heat next is comes from the giving up of the lights, some other motors, machineries, cooking operations like this. Next, heat liberated by the opponents. These are the heat carried out the outside air which leaks in. Heat came through the walls. The heat came from the fan. Next is comes the latent heat came. So there is an additional water vapor to the space in the enclosed space. Again, in latent heat is said to be occurred. It's said to occur. Latent heat, how latent heat will gain may occur due to the one of the following. Heat gain due to the moisture in the outside air entering the room, as the heat gain due to condensation of the moisture from the occupants. Means the moisture is coming, it is evaporating, and heat is gained. Heat is releasing the heat. The heat gains condensation of the moist convection from the sweat from the occupants. Heat gain condensation of moisture from any process, say cooking goods, which takes place within the conditioned room. Heat gain due to moisture passing directly in the conditioned space through permeable walls or partitions. Moisture, so everywhere the moisture. Moisture, how it is coming inside the room, maybe from the incoming with the incoming air, maybe with the from the body of the occupants, maybe from the some cooking utensils, so cooking going on inside the room, and maybe some permeable or vulnerable wall or partition from the outside or from the adjoining region where the water vapor pressure is higher. Then total heat is supposed to be removed by air conditioning and refrigeration equipments in the sum of sensible and latent heat loads. Now let us calculate the amount of heat gained through the building structure by conduction. Next, what happens here? The heat gained through the building structure, walls, floors, ceiling, doors, windows constitute the major portion of the sensible heat. Means the walls of the building, doors of the building, windows, everything, all these ceilings may got heated from the high heat of the surrounding sun rays, and it continues the heat in turns heated inside the room of your different inside of the different rooms of the building, and it contains, this is the major part of the sensible heat load which is coming inside the room. Now a building wall consists of a long single homogeneous material. Here it is shown here, and a little constant show that heat passing through the wall is first received. All the wall is received at the wall surface, exposed to the region of higher air temperature by radiation, exposed to the region of higher air temperature by radiation, convection and conduction. Then it flows through the material of the wall to the surface exposed at the region of lower temperature. Now the heat dispensed through the process of radiation, convection, and conduction. So what is going on? Heat passing through the wall is first received by the wall surface, exposed to the region of high temperature by radiation convection. Then it flows through the material of the wall, exposed to the region of lower temperature. Now the heat is dispersed through the process of radiation, conduction, convection, radiation. So next, the main contributor is the wall. It is exposed to the outside the heat radiation. Next, next comes the wall. Next comes again the wall. It is this heat is passing through this wall. Next, one side first received from the outside, then one side of the wall is exposed to the exposed to the lower region of air temperature. So in the wall, outside is the higher temperature, at the right hand side is the lower temperature. There is a very normal convection of heat by means of convection as well as radiation even. So the heat transfer under through a wall under steady condition is Q F0 F0 T0 minus T1 into A. Just a second. Now, the just now the heat transport or gain through the wall under steady condition is given as Q, the F0 T0 minus T1 into A into multiplies K divided by X T1 minus T2 into A Tf1 T1 minus T1 T2 minus T1 into A, which is equal to UA into T0 minus Ti. So F0 is the outside film surface conductance. F0, it is called outside film or surface conductance. Fi, F0 there is one Fi. This is Fi. This is inside film or surface conductance. These are different factors. A outside wall. This is given here. T0 outside air temperature. Ti inside air temperature. And X thickness of the wall. X thickness of the wall, which is given here. K thermal conductivity of the material of the wall, and U overall coefficient of heat transfer, overall coefficient of heat transfer of the heat transmission of the wall, overall coefficient of heat transmission of the wall, which is given as 1 divided by 1 by F0 plus X divided by K plus 1 by F1 Fi, where F0 you know outside film or surface conductance, Fi inside film or surface conductance, X is the thickness of the wall, K thermal conductivity of the material of the wall. Now, if you know these factors, you can calculate the heat transfer through the wall. Now, overall, this U is the overall film coefficient of heat transfer, and which is multiplied by the A, area of the wall, multiplied by the outside temperature minus inside temperature. So when a wall is made of layers of three different materials in here through a single wall. Here it is shown that the wall is a single wall, so which means there is a made of only one material, that is the wall here, and there is a air film here, thin air film of the outer side as well as on the inner side. And this is the thickness of the wall film, and conductivity, thermal conductivity of the wall is given as only K. But there sometimes it happens, wall is made of different materials. And then the overall coefficient of heat transfer will be given by the formula. This is the 1, 2, 3. That is three different types of materials are there of different thickness X1, X2, X3, and three different coefficient of thermal conduction K1, K2, K3. Now, the heat transfer, that's there may be there may be a wall with composite wall with air space.
हेलो गुड मॉर्निंग सर।
गुड मॉर्निंग।
सर जो डॉक्यूमेंट आपने शेयर किया था गूगल क्लासरूम में सर, मतलब रेफ्रिजरेशन का, उसी से आएगा ना सर?
हाँ।
ओके सर, थैंक यू सर।
Look, hello, Shubham.
यस सर।
What I have given in the exam, for the exam, vapor compression refrigeration, ठीक है? Refrigerants. Do you
यस
listen to
सर।
me? Last but not the least, psychometry. I have not given
यस
the vapor absorption refrigeration.
सर, वेपर कंप्रेशन रेफ्रिजरेशन साइकिल, साइकोमेट्री,
Yeah.
रेफ्रिजरेंट एंड
Psychometry first, okay? Refrigerants, ठीक है? Third is vapor compression refrigeration. I have given the notes for, I think, up to vapor absorption, I think up to देखा ना वो, but psychometry note আমি পাঠিয়ে দেবো, বুঝেছো?
यस सर।
In that
Yes, sir.
Google Classroom আজকালের মধ্যে পাঠিয়ে দেবো।
Yes, sir.
But go through your
Yes, sir.
খোঁজ নিয়ে আরে খোঁজ ডাউনলোড করলাম। There will be 10 questions. There will be 10 questions,
Yes.
3 descriptive and 7 objectives. 5 objectives, 3 descriptive, 8 questions.
Yes, sir. Sir, means numerical also, na sir? Numerical also, na sir, in exam?
Yes, these are numericals. Sums are there, totally sums, only numericals.
Yes, sir.
You have to write down in your
Only
paper, piece of paper, and you have to give me, send me the scan copy. And
Yes, sir.
there are
Sir,
5 objectives. That too you have to write down, not the questions, but the name of the question. Say question number 1, answer is say A or B. Question number 2, answer is say B or C, like this. Don't write down the question. That is not required.
Sir, and what is the role of camera, sir?
Yeah.
What is the role of camera, sir? I think camera must be on or given on notice, sir.
तुम्हारा ये है ना, तुम्हारा मोबाइल है ना?
हाँ, yes, sir.
ये मोबाइल से ये I will make it. I will open this class, ठीक है? In Zoom में मैं class open किया at the same time. You will open your camera and you will open that video. Here I am not viewable to you because I have made the video off. I will be viewable to you when I will make the video on. ठीक है? Same is the case with you. You will be viewable from my side, and you will write down. Just focus this camera to you and write down your everything, so that I can see.
Sir, my camera focus on the copy, sir, where I will be writing, sir.
क्या?
सर कैमरा का जो फोकस होगा सर वो कॉपी पे होगा ना, जहाँ पे आंसर हम लोग राइट डाउन कर रहे होंगे।
ठीक है তুমি ক্যামেরাটা আমার তোমার দিকে রেখে একটা কিছুর উপর লাগিয়ে দাও, ব্যাস হয়ে গেল। ঠিক আছে, and you write down the answer in front of the camera, that's all. That is the matter.
Yes, sir.
After all, make a quick and make a scan copy and send submit to the classroom.
Okay, sir.
ठीक है?
Okay, sir. Thank you, sir.
Okay, all the best. Acha. What I am saying that heat transfer through a composite wall with airface. So there are the walls have the difference between them. This is adjacent to each other, but there is a gap here. Means there is some space or some air is left here. So there is a air film here. There is the air film here. There's another air film here. So all have the coefficient of thermal conduction K1, 2, 3, and Ka, and they have the differences. They have the gap among themselves. So let us go through what will be the coefficient of thermal expansion, thermal coefficient of heat transmission of the wall when there is a different type of wall material is there. That is 1 divided by 1 by F0, x1 by K1, x2 by K2, x3 by K3, plus 1 by Fy. x1 and x2 and K1, K2 as a space as well as coefficient of thermal expansion respectively, and in the thickness of the coefficient of thermal expansion respectively. This part of walls are made of a cold storage with a minimum low temperature insulation of 10 centimeter. These types of walls should have that is made for generally cold storage with minimum low temperature when you have low temperature insulation of 10 centimeter. When airspace is provided between the materials, then the overall coefficient of thermal expansion is given like this in the same fashion, except for that for the airspace, we are not considering the thickness of the airspace or gap of the airspace. Only we are considering the coefficient of thermal expansion through the space of the air. And other case where there is a material, there's different materials of the wall, to make the wall X1, X2, X3, these are all same. In case of interior walls or partitions, floors, ceilings, the temperature of the adjacent space is usually 5 to 10 degrees centigrade lower than the outside design temperature. So what we are supposed to do, we should see that temperature inside should be around 5 to 10 degrees centigrade less than the outside temperature, average outside design temperature. But for kitchens, boiler rooms, articles, it is often higher than the outside temperature. Please, when the inside space is full of inside space, we have a high thermal conduct heat producing materials, like say you have some big kitchens in a hotel room, say boiler rooms, some attics, some show windows like this. It is often higher than the outside temperature. The value of the overall coefficient of heat transmission for structures, thermal conductivity of the building materials and insulating materials, the conductance of building materials and obstruction and film or surface conductance for air film or air spaces are given in the following tables. So first of all, we have to know the overall coefficient of heat transfer for structures. What is K1, K2, K3, K3, and K1, etc. Then thermal conductivity of the building materials on the overall coefficient of heat transfer for structures. So different structures, first of all. So, and thermal conductivity of building materials and insulating materials, conductance of building materials and structures, and film or surface conductance for film and airspace. So what we have to do, first of all, first we have to know coefficient of heat transfer for structure, what can be the thermal conductivity of the building materials and some internal materials, what is the conductance of building materials and constructions, and film or surface conductance for film, and air spaces. What is available here? This is F0 and F1 is the conductance of outside film conductance, and F1 is called Fi is called inside film conductance. Inside film or surface conductance. So what we have to know, what is the conductance of building materials and constructions, outside, inside. Then what is the thermal conductivity? It means this is given as K here, thermal conductivity of the materials. So you have to know the thermal conductivity of different building materials and overall coefficient of thermal contraction for structures. So for individual thermal conductivity, visual conductance plus overall coefficient of thermal conductance, these are given in the following structures here. Say different type of bricks walls of certain thickness, hollow tiles, cylinder bricks, cylinder blocks, cylinder bricks, cylinder blocks, clip walled single, a clipboard frame, all these things. The overall coefficient of heat transfer is given as so many watts per square meter of the area plus multiplied by the in terms of kilowatt. Then watt per square meters in per kilowatt. There's so many factors are there. Next comes the thermal conductivity of different materials. In the same condition, watt per meter square, it should be per meter. It is per meter square here. Overall thermal transmission, thermal conductivity is per meter in per meter per degree Kelvin. Or sorry, watt per square meter per degree Kelvin. Watt per square per meter only per meter per degree Kelvin. This is the thermal conductivity K. And as this was, these are the different factors given in the factory. Conductance is given in watt per square meter per degree Kelvin. Per rise and fall in Kelvin, like this. So film and conductance for film or surface conductance, or where This is film conductance of building materials, film or surface conductance. These are all given from this available from this chart. The above values of thermocouples are on a mean temperature of 20 to 30 degrees centigrade. Next comes the heat gain from solar radiation. The solar radiation striking the outward surface of a building may contribute appreciably to the peak load on the air conditioning and refrigeration equipments. What is this? The solar radiation is striking the outside surface of a building may contribute appreciably to the peak load on the air conditioning and refrigeration equipments and must therefore be considered. The amount of heat that flows through the interior of a building due to solar radiation depends upon the following factors. Attitude, angle of the sun, clearness of the sky, attitude, angle of the sun, clearness of the sky, position of the surface with respect to the direction of sun's rays, absorbability of the surface, ratio of the overall coefficient of heat transfer of the wall to the coefficient of heat transfer of the outside air film, temperature of the ground and surrounding objects with which the heated surface may interchange radiant heat. Temperature of the ground and surrounding objects with which the heated surface may interchange radiant heat. So what is going on? The amount of heat flows through the interior of a building due to solar radiation actually depends on these factors. What is the altitude angle of the sun? What is the clearness of the sky? Position means how clear the sky is. In a cloudy sky, you can get the sun rays. The angle of attitude, it may be on your right, on your over your head, or it can be at an angle with the edge. Next, absorbability of the surface. Absorbability of the surface. The ratio of the overall overall the heat transfer of the wall to the coefficient of heat transfer of the outside film. Ratio of the overall coefficient of heat transfer of the wall to the coefficient of heat transfer of the outside film. And the temperature of the ground and surrounding objects. Temperature of the ground and surrounding objects with which the heated surface may interchange radiant heat. The altitude angle of the sun, in turn, depends upon the altitude of the locality, season of the year, and hour of the day. The altitude of the sun, in turn, depends on the altitude of the locality, season of year, and hour of the day. The altitude angle is actually depends on the altitude of the locality, season of the year, and hour of the day. Then what is the locality? Maybe ground floor, maybe what is the year, what is the position of the year, say maybe in December, January to be heat, and hour of the day will be the condition of the day. It's like this. The heat from the solar radiation is received by building surfaces in two forms. That is direct radiation and sky and diffuse radiation. Direct radiation and sky or diffuse radiation. The direct radiation is the impingement of the sun rays upon the surface. Direct radiation is the impingement of the sun rays upon the surface. The sky or diffuse radiation is received from the moisture and dust particles in this atmosphere, which absorb part of the energy of the sun's rays, therefore becomes heated to a temperature above that of the air. The same sky radiation is received by the surface which do not face the sun. The solar heat can be sensible through outside wall and roofs. Next. So what we have got out of it? First of all, how we will get the solar radiation. There it is depends means how much heat you are absorbing from the sun rays, and what is the altitude angle of the sun. But it depends on the following factor. What is the altitude of the sun? Altitude angle means from sun is coming from a few lakhs of miles away, but it has at certain it is sending the sun rays at an angle with the angle from the sun itself. The clearness of the sky. This sky may be cloudy or clear. It depends on the radiation, so depends on this. The position of the surface, from the sun, from where your house is located, then what is the direction of sun rays? It may be from the top, maybe side, maybe from an angle. Absorbability of the surface. Ratio of the overall coefficient of heat transfer of the wall to the coefficient of heat transfer of the outside air film. And the temperature of the ground and surrounding objects with which the heated surface may interchange radiant heat. The altitude angle of the sun in general depends on the altitude of the locality, seasons of the year, and hours of the day. The heat from the solar radiation is received. Actually, the altitude of sun in turn depends on the altitude of the locality. The heat from the solar radiation now received in the building has two forms: direct radiation or diffuse radiation. The direct radiation is the impingement of the sun rays up the surface. The sky radiation is received from the moisture, dust particles on the atmosphere, which absorb part of the energy sun rays and thus becomes heated and by 12 temperature above that of the air. The sky radiation is received by the surface which do not face the sun. Solar heat came through the outside walls of the room. Now, next here, let us find out what is the heat radiation. Heat came through the outside walls and the rooms. The transmission of heat through the walls exposed to the outside, and roof is not steady. That is, flow of it is periodic due to the variation of the outside temperature. Solar radiation, radiation is at a period of 24 hours. For a 24 hours means throughout the day, this amount of heat transferred through the wall is not fixed, but it is variable. And a little consideration will show that temperature of the walls rises with the rise in outside temperature, and heat is stored in the wall, which has a considerable storage capacity. This heat transferred to the room is thus the heat transferred to the room is reduced. Stored heat of the wall is then given up to the room when the outside temperature falls. Actually, what happens? The outside temperature is raised, outer of the wall rises with the rise in outside temperature, and the heat is stored in the wall, which has a considerable storing capacity. So part of the wall heat is absorbed by the wall itself, and it keeps there and waiting for the considerable storing capacity. Now, a little consideration will show us the temperature of wall rises with the rise in the outside temperature, and the heat is stored. Considerable heat is stored in the air, but when heat transferred to the wall, heat is a good amount of heat is stored, but wall is storing the maximum amount of heat, and it is not allowing the heat to be removed before it is heat to be removed to the room before it itself is heated to a considerable amount. Next, the heat transfer of the wall generally does not take place because wall absorbs heat from the sun rays, but stored heat given off. But when outside temperature is reduced, the stored heat is given stored heat in the wall is given to the room as well as given to the outside. We have to consider extent. Since the outside temperature changes continuously over a period of 24 hours, therefore instantaneous heat gains through the room, inside the room, inside the room. And so outside temperature changes continuously in the period of 24 hours. And therefore, the instantaneous gain from outside is not equal to the instantaneous gain inside the room. So what we mean by instantaneous heat gain means outside when the heat is gaining, it is not directly transferred to the inside of the room or rejected by the room, rejected by the wall. The heat stored in the wall is given off later in the evening. The amount of heat stored in the wall is given up in the room when latter part of the evening when the outside the wall is getting cooler. The peak of incoming heat is delayed by the storage effect of the wall, and it is also reduced. Now here the figure shows the curves of instantaneous load from outside. What is going on? Say this, what is shown here, the curves of instantaneous load. It is from 6 a.m., 10 a.m., 2 p.m., 6 p.m., 10 p.m., 2 a.m., 4 p.m. like this. Throughout the different times of the temperature, instantaneous load from outside, actual load inside the room. The shaded area above the actual load shows the heat stored, and below the actual load shows the heat released by the walls and other substructures. A convenient method of taking into account this lagging effect of storage and the solar radiation is to use equivalent temperature difference. The equivalent temperature differentials for roof are given in temperature 19.6, and this applied to walls is given in table 19.7. The heat gain through outside walls and roofs is given by Q. Q is equal to Q into A into T. The heat gained through outside walls and roofs, and the convenient method of taking into account the lagging effect of storage and the solar radiation is to use an equivalent temperature difference. The equivalent temperature difference of the roofs are given here, and those applied to the walls are given next table. The heat gain through the outside wall of the roof is given by Q, U into A into T. Overall Q, U, overall heat transfer coefficient of the roof or wall, A, area of the roof or wall, and TE, equivalent temperature differential. So what is given? There's 2 centimeter wood or something, 2.5 centimeter installation of 5 wood, all these things. The sun time is from is 12, 38:54 a.m. and sometime is here 64:58, 16:0. And finally, these are the expected sometimes. The equivalent total equivalent temperature differential. Then what is the difference in temperature? That is the temperature difference 8, 10, or difference in temperature, or what is the difference in temperature through inside and outside? That is 8, 10, 12, and it is going up. For the roof construction is comparatively less. Through the walls, light construction, it is more. The medium construction roof, it is comparatively less, but still it is considerable. Like this concrete, gypsum, wood, all these things, if you construct, the different temperature differentials like this. Inside includes 9 centimeter lead. Next, the concrete, it is compared even less than that. And there's some heavy construction, it is the temperature differential is considerably less. So there will be considerable less amount of heat will be transferred. So there are light heavy construction, That is the for roofs. This is for roof. Roof constant depression was not much less than that. Next, total equivalent temperature for calculating heat gain through sunlight. This is the north latitude, south latitude. This is the sun time is given and differential is given also. The northeast, east, southeast like this. This is the frame, this side of the wall, maybe northeast side, southeast, west like this. And what is the differential between south latitude here? This is the south latitude. You have to go from here, and north latitude, this is go from here. These are the different potential differential, different type of say brick wall of different thickness, hollow tile of different walls, all these things. So 100 corner wall or so. Okay, I'm finishing today for the day.